Okay. Anyway, so what I was trying to say is it is broken chain. So we do have this practice of having this mainstream story and neglecting all the other stories. So the story which I am telling from now onwards is such a neglected part of computing history. You will not find these stories in mainstream storybooks about computing. Everybody will speak about maybe marginally about Charles Babbage and others, but they will never speak about the people whom I am talking about. So you should be very careful while listening to such stories because nobody else will tell these stories. So yesterday we had seen the lives of these two guys. One is Charles Babbage, whom I consider as the grandfather, and Herman Holland, whom I consider as the first hacker ever to come to the world. This subtext which I am starting now, all the people whom we are discussing today and in the next few classes, they don't carry the legacy of engineering. They brought in a new legacy into the history of computing, that of mathematics. See, there is a wide difference between how a mathematician will encounter a problem, will tackle a problem, and how engineers will solve a problem. There is a profound difference, right? By now you know. What is the precise difference? How will engineers solve a problem and how will mathematicians solve a problem? Stereotype roles, mathematician and engineer. What is the difference? How will mathematicians solve it? How will engineers solve it? How do you solve problems in mathematics? What is mathematical way of solving problems?
The engineer's view of solving the problem is more, they look at the problem in different.
Yeah, what is the difference?
They'll take instances from the real world, real data, and then do the analysis according to that, then frame the...
How will mathematicians solve it? Huh? Let me get something. Try to solve. Okay. Well, I thought I'll skip this part because now that you are very near between engineers, there is no point. Anyway, that's not try to simply talk more because I can go on talking about this. I'll try to be as brief as possible when talking about this issue. See, mathematicians at the end of the day are not worrying much about economic solutions. Engineers are obsessed with economic solutions. For a mathematician, economics is not a concern. Perhaps beauty, aesthetics, they have some concern. Efficiency is the utmost concern. No compromise about it. For an engineer, economy is the main concern. That economy could be anything. That could be that of power in the sense energy resource. Mechanical engineers and all worry about it. How to efficiently use the energy and all. For us, the computing engineers, we have our own resources, space and time and other things. We have our own abstract ideas on how we should solve the problem. That is more important for us. So when I am trying to solve the problem, I am obsessed with giving an economic solution to the problem. And more importantly, a working solution is more than important. I have my favorite example, I think I have told this 100 times, but I don't mind repeating it. Basic difference is this. If you open the tap, how the water flows is more obsession of the mathematician, modeling it and all. There will be not a clear flow of water, there will be turbulence. What kind of turbulence? What differential equation? He will start doing all. Our obsession is not all. Water is flowing? Fine, what to do? What is the best way I can use it? Roll model I often say, Vishweshwaraya, see the water falling and say what a waste, and then build hydroelectric power. That is how we think. Whereas, as I often say, Yogaraj Bhatt sees that water falling, he should remove it and make loads of money out of it. See the difference. Right? That is the difference. How we view. At the end of the day, engineers, like what you have gone through the 4 years torture, which is nearing its completion somehow, we are supposed to train you in that mindset, not teaching you that language, that technology, this technology, communication skills, dressing up well for interview, not at all. At the end of the day, if you can see the problem as an engineer, this is the question which we are increasingly asking ourselves as educators. Are we telling our students that this is what you need to be as an engineer? But trying to find an answer to this question and all is very depressing, so I won't go anywhere near. So the basic difference between mathematicians and engineers is this. If you see the Hermann Alvarez and all that stories which we were talking yesterday, they were obsessed with solving a problem. There is a problem, I have to solve it with the available machinery, whatever technology is available in the day, I have to solve it. If it works, fine. No questions asked. It's not the case with mathematicians. Mathematicians, if you give them, for example, their most celebrated act is proving something. It is not enough if you say that, for example, a given equation works for all cases. Are they happy with that? No. They need a proof. If they have proof, they are happy. Of what use is a proof, nobody knows. If you sit back and think, what is the need for a proof in mathematics? From an engineering perspective, if it works, it works. If I drop this vessel, it will fall. Okay, I know it. So I will do whatever mechanism required. If I have to suspend this in the air, I will give some support. That's how I think as an engineer. I will not be bothered with why does it drop and it's drop. Not so for a mathematician. He needs to prove. And that proof is something holy grail for them. There is no use, but they want it. This is very important mindset. Remember this. We will use it somewhere else. There is no use, but they want it. And they will do all that is possible to find that truth. They seek truth. Philosophically, they seek truth in their own way. Fermat's last theorem. Fermat's last theorem. What was the need for so many people to sit and struggle for so many centuries? What was the need? What was the need? X square plus y square is equal to z square. In general, x to the power of n plus y to the power of n is equal to z to the power of n is applicable only for n is equal to 2 and not for any other number. Okay, fine. What is the use of finding a proof for this? Did they do? No. Some Fermat said somewhere it seems.
In a margin.
In his margin, because there was no other place. He said, I saw it, I have a proof, but there is no place to write it. What a provocation. All mathematicians said, okay, we'll solve it. Centuries together they tried. Finally, Andrew Wiles,
1983.
that man came and solved it, proved what happened after doing. I hope you have seen the documentary. He becomes very misty-eyed and all, same there. One day I was working in my home. One afternoon I thought, finally I have solved it. I came back, had tears in my eyes. I told my wife that I have solved it. He says, great emotional value is attached to such events, celebrated events. What happened after that? some 500 pages of proof. First of all, you hear it, and then again, after it is published, you find out some problem with it. Again, this guy should go. Again, he should say, for years and years, not years, it's a few, 1 year or something. Again, publish one more proof which was accepted by you. Sort. Check. This is mathematicians. So mathematicians have this in their blood. They want to go to the root and they want to build everything step by step. And they prove something. Now the people whom we are talking from now are all mathematicians. You should have this in mind. So mathematicians have this in their blood. Through training, through seasoning. Nobody who doesn't have in them these qualities cannot become a mathematician. Being a mathematician is not easy. It's very easy to become engineers and all. But being a true mathematician is very difficult. So, when mathematicians entered computing, precisely during this World War II, things changed. I think mathematicians brought with them two things. One is they brought with them the rigor which was required for computing. And second, they brought certain culture along with them. Mathematicians thrive on openness. If you have seen Fermat's last year documentary, you will generally understand how proofs are built in mathematics. How do they build a proof? That man does not start from x is equal to 1 kind of a thing. He does not start from there. He will pick something from someone, he will take all those ideas, put them together and build his proof. They have this culture of openness. If somebody had said something, they will not think that this is private property. For them that is public only. They will just go get it and put them in their proof. Done. Once a mathematician proves something, it is not his private property, it becomes a public property. Now this culture was there in mathematicians, they brought that culture along with them to computing. Understand that computing at that time was becoming industrialized. IBM was running its show like it's running a normal factory. Engineers of IBM meant that they were wearing all the suit and ties and everything and all. There was a factory culture. In contrast, mathematicians brought to computing this open culture that came through mathematicians. And two guys who brought this color to computing in their own way. One was John von Neumann. John von Neumann was a colorful personality. I often at awe with his personality. It's because of two reasons. One is, I think it's high time that all teachers consider Neumann as modern. Because in India, we have this tradition, not only India, every culture, I think there is a tradition. Whenever we say teacher, we always have a prefix, poor teacher. You see any of the Indian stories, old Chandavama stories. If there is a character of teacher, he will always be poor. And if he is a Brahmin also, he will always be poor. Bada Brahman always. Chandavama always Bada Brahman. There will not be any wealthy Brahmin. Brahman is always poor. Teacher is poor. So, Brahmin teacher should be poorest. So, India we have that. Even today that's it. Teachers will be poor. They build parking lots now, cars and building parking lots. That parking lot is for students' park, not for teachers' car park. Teachers will not afford all those building students. That's a tradition. Isn't yarrow that who was some senior people from Iran. They came to me and I told them, sir, they quoted some poet, some Persian poet. They told God is very close to teachers. Because teachers don't like gold, in the sense that teachers don't care for wealth much, therefore they are very close to God. Some Iranian student told me. It was free. So I think in agriculture this is like, teacher means there should be poor. Things are slowly changing, but long way to go. So teachers should consider how Neumann is a model because he was a teacher who was having his own private jet. Private jet. Living life king size. You are such a teacher. So I think we should keep him as a role model. He actually trained himself to become a chemical engineer because his father wanted. Like most of him. His father wanted him to become an engineer, so he became a chemical engineer. Then he was a genius, born genius. So he decided that I want to study mathematics. So after completing his engineering, the very next year he completed his PhD in mathematics. And because of his brilliance, he was, because of the political situation in Europe at that time, he moved to US. US gained a lot because of this Nazi thing in Germany. All the Jews, they moved out. And if you see most of the early pilots in company, most of them are from Jewish background. They are migrated. So what was Germany and Europe's general loss was America's gain. So this John von Neumann came to US, he came to Princeton. All this happens in A-class schools. Institute of Advanced Study in Princeton, the place to be at that time where there were some very good mathematicians, including our beautiful mind guy, all of them were there. In fact, Turing also was there. Turing also was there in Princeton at that time. So every fertile environment, John von Neumann made his entry. What is his major contribution to us?
Separating memory and processing.
Yeah. He made it by mistake or intentionally, we don't know. But his legacy is that he separated memory and the processor forever, posing us problems even today. Even today we are struggling how to solve this problem. So he did that, and one of his other very important achievement is that he designed, I mean, you say single-handedly, but I don't know. The first electronic computers for the purpose of military, of course. They were the biggest sponsors of computing at that time and for a long time. So he did that. There is something very, very interesting apart from this fact about Neumann. He is also the father of one more important area which was not used in computing for a long time, but subsequently we are using it. At least I am trying to use it. It's called game theory. Like somewhere in our studies you might have encountered game theory. Game theory is a very interesting application of mathematics to solve certain problems in economics and generally of human behavior. He started that area. So his contribution is there in computing, in economics studies, in building of computers. Genius thing. So he led a very colorful life. There are many personal accounts which are told about one night. Some of them may not be appropriate for me to tell in class. Outside the class I can share. Very colorful personality. I think that's enough. Because I may tell something in the mood, so I don't know. I'll quickly turn to another person whom I wanted to discuss. Alan Turing. This Neumann and Turing, I want to give them both the title of father of quantum computing. I think we can accept two fathers, it's okay. It's okay because I'm sentimentally attached to both of them. I can't leave Neumann because of him all this problem of storage came and files came and file structures. File structures is very important for me because I've written a book and all. So I can't leave Neumann. Neumann was not there, I wouldn't write the book. So I want. And file structures as a book is very closely attached because some personal history there.
Challenge.
So Neumann is father. And Turing also is a father because he was a brilliant guy and because of the, see these guys who die early or die a tragic death, they have some, what should I say, some kind of attraction to their life. You can build some epic stories around them. They die young. For example, Ramanujan, mathematician Ramanujan, they are died young. So they are made some, their stories are some kind of epic stories. Back when Ramanujan died, his close friend Hardy said there is no loss. Hardy was mathematician. He said there is no much loss. Actually, world has not lost much because Ramanujan died. Because he says all the work of science and maths and all, people do it at their young age. If they become old, they will be useless. Whereas people who pursue arts and literature, they bloom late. Who was that musician? Who was that musician? Who spent some 14 years in silence and suddenly woke up one day and said, yeah, I can compose those. I'm not able to recall the name. So the point is that literary minds bloom late and scientific minds should come early. Alan Turing's case is like that. Alan Turing's legacy is too much. You know how we are celebrating him. Our highest award is named after him. Alan Turing's contribution, I think, is in two ways. One, because he gave us the idea of a universal computer. All of you have studied the Turing machine. Not a physical machine, but a mental concept of this machine which can solve any problem, provided that you can write an algorithm to solve it. That is the basis of today's digital computers. His legacy is largely due to that. And also I think his legacy is due to the fact that he gave us Turing test. Turing test. The ultimate test which is used even today to test whether a machine has intelligence or not. So Turing was thinking upon this question, can machines think? Becomes an important figure because he influenced many others to think like this. So these two important contributions of Turing I think we should never forget, and therefore I consider him as the father of modern computing. Of course, although on a personal front he had to suffer a lot. Much of his work has been classified. What we know because he was working during World War II, and much of his work was to break that code, Enigma, which Nazis were using to send messages across. He was the man who actually built the machine, the computer, which would break this code coming from Enigma. In fact, it was said that the war would never have been won. They may have won the war, but not so soon if Alan Turing did not build that machine. Thanks to that machine and their ability to crack the enemy code, they were able to win the war faster. That was his legacy. But his personal life was not that great. You know what brought him on. He was prosecuted because he was homosexual. It was crime at that time in England to be that. And because he was prosecuted, he was very depressed and he died. He committed suicide. I had said that this apple plays a very important role in computing. That's because of the apple's relation to Turing. Turing injected cyanide to an apple and ate it in that. So you can start the story Adam eating apple. Why did Alan Turing choose apple? Should tell some novelists. They'll write some good novels, pop novels. They're looking for this kind of stories. Right. So Alan Turing died. Committed suicide. How ಹೇಳಿದ್ದರು great class. Apple, remember Apple, it will come again. Now it doesn't happen. Story of Apple. Actually, in 2009, the Prime Minister of England, Mr. Brown, apologized publicly on behalf of the government of England for prosecuting Alan Turing, the war hero. Yeah, public apology was given, but what happened. If he had stayed a bit longer, probably we would see much more invention. Because during the time of his death, he was much obsessed with the idea of computational life, not artificial intelligence, but artificial life. He was obsessed with that. He had even given some introductory talks on that subject. But these personal events and he died, and not much improvement has been done in that field for a long time. In fact, the full, what should I say, the power of artificial intelligence, even today we are not able to understand. That will come later. After Alan Turing, I think the one person and one small story which I will end today's talk is that of John McCarthy. John McCarthy again was a mathematician. Why I am remembering John McCarthy, who is still very much alive, I think. Who knows? Some of you, if you go to Stanford, it is a possibility. You can actually meet him. Actually, somebody from this class can. 3-4 of my students are in Stanford. One very unlikely lady, I never thought to go to Stanford is in Stanford. She was playing basketball all the time, and I used to tell her she was very intelligent. I used to tell her, please, if you focus a bit here, you will do wonders. She was not doing. She was playing basketball all the time. But now she's in Stanford. She's in the web designing committee of Stanford, and she keeps writing to me asking how to do these changes to the website. Some of you may even land up in Stanford and one day have a chat with McCarthy. McCarthy becomes very important in my storytelling because as a mathematician, he suddenly became interested in computation. Not only became interested in computation, but he came to MIT, where our action will take place. He came to MIT and started a project. It was called Project Mac. Project Mac originally meant not machine, that was the next name. The original name was Mathematics and Computation. That was the project name. Very innocent sounding name actually. It does not say what was happening in that project. That project's aim was to build this machine which could play chess. That was interesting. And he is the man who coined the term artificial intelligence. It was John McCarthy who coined the term artificial intelligence, which became the key word for everything that we will be discussing from now on. Artificial intelligence. That machines somehow should have intelligence. This artificial intelligence, unfortunately, I don't know for what reason, is today not at all present in our knowledge. I don't know the reason. It's not there. It is not like this. When I started my career here, I was lecturing on artificial intelligence. But today there are no courses on artificial intelligence. What changed in these years, I don't know. We had a very strong AI club. There is a culture, AI culture. Any institute which has a vibrant artificial intelligence culture will survive for a long time. That's what I understand. It's only that field which has the power to keep people thinking in many new ways. That field has it. In the course that you have studied, I think the entire artificial intelligence chain is missing. I don't know if there is something happened. I should go back and look what happened. But it's not there today. If you see, not only here, it's not there in computer science. It's not to be found in mechanical engineering, where it was so some good programs are offered in mechanical engineering. It's nowhere. I don't know why artificial intelligence has suddenly gone out of it out of fashion or something? I don't know.
It was offered as an elective in CS.
Yeah, but the core is not. Core in the sense the chain of subjects leading to artificial intelligence. Artificial intelligence finally is the climax. The leading subjects to it. It's not there. I hope at least in Tamil Nadu after it will start now. Seriously about artificial intelligence. The Rajinikanth effect, if it's carried out, I will be very happy. Are there any Rajinikanth fans here? Will offer it So John McCarthy coined this term called artificial intelligence, and not only that, he gave a language to it. Lisp. Actually, I was teaching Lisp. Very interesting language, very intuitive language, which was the language to be used in artificial intelligence. John McCarthy's project, which was called MAC. Then people started calling it man and computer and all. The original name was mathematics and computation. This project aim was to build this machine which could play chess. Why? Because chess, all of us understand, is a very intelligent game. And then if machine plays chess, we can prove that machine is intelligent. For all reasons I know, John McCarthy has written only one story in his entire life. Have you read that story? Very wonderful story. Called Robot and the Check. A very small story, 5-6 pages story. Please read it. Robot and the Check. That's a short story which he has written. I think Shankar may have read that story. It was in Yantiram. There was a strong influence of this story. Who knows? I know the story was written by Yantiram story writer was this person. What is that person's name? That person who died, he was working in BL. Actually, that is the he is the man actually who designed the EVM, the electronic voting machine. That is done in BL, you know. That the engineer who designed the BL is actually the story writer for most of Shankar's movies and Rajinikanth's movies. Many people don't know. He died recently, and he gave the story to Shankar, and then the movie was made. It has a strong resemblance to John McCarthy's short story, Robot and the Child, wherein it's a futuristic story. Story happened in 2055, wherein robots are doing the jobs, normal jobs of housekeeping. But to prevent some kind of attachments, wrong attachments happening with children, I think probably McCarthy was thinking about my favorite movie, which I think among all robots, AI. AI was based upon a story that suddenly robots become sentimental and become attached and all. I hope you have seen the movie. Probably McCarthy was thinking something about that, and he designed some rules for that robots should not speak with small kids and all. And it so happens that there is this robot and there is this mother who is alcoholic, drug addicted, and single mother. Because she can't take care of the child, there is this robot. But robot has a standing instruction that it should not take care of the child. It should only follow the order of that parent and do all the housework. And in one day what happens, the lady is very drunk and the robot comes and complains to the lady that, see, the child, you must feed the child now. The child is some 1.5 years and something. You have to feed the child, otherwise it will die, its temperature is going down, and all that you have to give the report. And then the lady will get angry and she will say, if that is the case, you only take care of the child. Now robot is in a dilemma. It is programmed in such a way that it should not take care of that child because of various reasons. It's pre-programmed. And one of the conditions there is that it should always listen to its owner. Now owner has asked that to take care of the child. Now what should it do? Logic. McCarthy explains the whole sequencing using his Lisp language for common people. It's a very interesting problem. If that is the case, then how will we solve it? Priority based, how will we solve it? Then finally it decides that it should do it. Then it decides that the emotional attachment. The robot makers have designed the robot as an ugly looking animal, not as a beautiful looking, because the kids may get attached to it. Then the robot changes its appearance as a doll and all that, and changes its voice to resemble what it calls a motherish language, and goes and carries the child and takes care. And suddenly the lady becomes very angry one day and she says, walk out of the home with the child. It walks out. What happens next is the actual story. You read the story. Now you read the story. It's a very short story. You can read it in 1 second. Robot and the child. John McCarthy's story. So in this fertile environment was created in MIT now. Now there were mathematicians who believed in openness, who came with a new idea of building intelligence into the machine and doing new things in the using computers. Of course, John McCarthy, after a short time, he left MIT and joined Stanford. But this project, Matt lived in MIT. Minsky and others continued the project. Where our next set of players will come. Probably tomorrow I'll start discussing. So this was the situation where the next set of people who Stephen Levy calls as the heroes of computer revolution came. The original first generation hackers came, and how they changed the face of computing we'll see from tomorrow. Let's stop.